Hello everyone, in this video we are going to talk about how to transform quadratic functions. We are going to learn about translating them, reflecting them, and rotating them. So they both have kind of formulas that you can apply, or you can actually think about what that means and then figure out how to write it out. I'm going to use the formula method in this assignment. We are working on IXL BB.4 Transformations of quadratic functions. So let's get started with the first question. It says find g of x. That just means a function where g of x is the translation 6 units down of f of x. So basically there's this f of x function, and x squared function is kind of like a popular guy. It looks like this. It should pass through the center. So just imagine that it touches the center, okay? If it says translate it 6 units down, it tells you to basically just take it down 6 units. How are you gonna take the whole thing down 6 units? So what we do in this case, we just keep the shape the same and then think about the point or points that we can move, like the one in the center, right? So move it down 6 units. So let's say this is -6, and the center of the curve would be at that point, and then the behavior would be the same. It would look like this. So the arms would go on forever. That's what the arrows indicate, but that's how the figure would look like. But how do we write the equation of this? What kind of formula do we have? So let me just give you a few examples of transformations, then I will explain what they do. For example, let's say we want to take, let's say the function is x squared, just to keep it simple and aligned with the question given. And if we want to, let's say this one is 6 units down. Let's just start with up and down movement. Okay, let's do first up 3, up 1, down 2, down 4. Now let's see how that would look like when we apply these translations. So up and down movement is all about, look at the variable on that axis, that's the y. So that's all about the y value. The y value, when you translate it into functions, is all about f of x. So in here, for example, f of x is whatever you see. It equals to whatever you have on the right side, right? So I have x squared, that's my f of x. If I had x on the right side, that would be my f of x. If I had like x plus 7 or x minus 11 or whatever you have on the right side, it doesn't need to be just one term. It could be like a lot of things on the right side. That whole thing, whatever you see on the right side, is your function, is your y value, is like this, okay? So when you say, or when I say up 3, I'm telling you to add 3 to the whole value. When I say up 1, I'm telling you to do plus 1 to the whole value, because looking at the vertical axis, look at the numbers and the way they are set up on the y-axis. This is just 1, 2, 3 on the y-axis for f of x. If you say plus 1, plus 2, plus 3, those are all about moving it up. And then when you say -1, -2, -3, and so on, they're all like about pushing it down. Now, when it says up 3, basically it tells you to do plus 3 in the end. In the end of what? Your right side, your function, the value of f of x. So you take your function, x squared, and then do plus 3 in the end. That's how simple it is. The vertical translation is the easiest one. If it is about vertical movement, it is about up and down movement, then that's the easiest one, because logically what you see or what you read is basically what you need to do by translating it into mathematical expressions. So up 1, like logically it should mean x squared is our whole function. That's the y value we have, because remember, f of x and y is the same. The only difference is y expresses a line or like a curve f of x expressed as a function. Now, plus 1. Down 2 basically is telling you to subtract 2. So write down your original function and then subtract 2. Write down your original function, subtract 4 this time. That's the logic behind it. The vertical movement is the simplest one. If it tells you to go up or down a unit, and then you just use the sign associated with that movement and then put that number. Now our question is about translating it 6 units down. The function we have, but what are we translating? We are translating the whole function we have. This is our function. F of x is on the left side and it equals to x squared. So move it down 6 units. Subtract 6 from it. X squared minus 6. Okay? So now that's how we do the translation. And again, if it says go up, the first 2 could be used as your examples. Now let's move on to the next level and see what type of questions we have. Now, horizontal movement. So the first one was about vertical movement. Whatever you read is going to be translated into mathematical expressions the way they are supposed to. With the horizontal movement, you got to kind of like think opposite. If you're going to think about the coordinate plane, when you see the word right or left, now you got to kind of do whatever you feel like the right thing. You got to do the exact opposite of what you think is the right thing. Let me explain what I mean. Just think of a coordinate plane, okay? When you have, this is the y-axis, this is the x-axis. All of the positive numbers are on the right side, right? 1, 2, 3, 4, and then if you see the word translated right 3 units, basically do the opposite. If you see the word right, all of the numbers on the right side are positive, but that's not what you're going to do. You're going to put a minus sign. Okay, just you'll subtract that number this time. But you're not going to put that number in the end of the function, because if you do that, like remember, let's say this is the function is the same. Let's take that function and try to figure out what we need to do. This is translation 1 unit right. I don't want to use that number. Let's just use right 2 or right 5, left 3, and left 1. Now, again, when you start dealing with horizontal movement, right and left translation, then do the opposite of what you feel like is the right thing. So looking at right 2, it feels like I need to add, but you're not going to, you're going to subtract. So that's how I remember what to do as a high school student when I was in high school. So take your original function. Let me show you something wrong first, and then I will correct it. I told you to do the opposite of what you think is the right thing, right? If you do this, that's going to be wrong, because what you are doing is you are subtracting 2 from the whole thing, from your f of x function. So when you do this, what this tells you is move it down 2 units. That's what it means. We just did it in the previous example. If you subtract or add a number in the end of the function, that's all about vertical movement. So if you're not going to subtract it from the whole function, if you're not going to put that number in the end, where do you think you should put that number to? So you are going to attach that number right next to the x. Okay? So in the original function, what we have is x is squared, right? X is squared. So we will take that x first, and then right 2 feels like we need to add 2. But remember, when we deal with horizontal movement, we want to do the opposite of what we feel like is the right thing. So, but we are not going to just subtract it, because the variable is squared in the original function. That's our original function right here on the left, and it equals to x squared. So v squared, the variable, when it says move it right 2 units, it tells us to subtract 2 from the variable, not from the function. That's the difference. With the vertical movement, we subtract it from the function. With the horizontal movement, we subtract or add it to the variable. Okay, so now I am done with the variable. I played with my variable, I have it, now I need to square it, which is why I put the whole thing in the parentheses. That's what we need to do. Write 5 unit tells you to subtract 5 from the variable, not from the whole function, because if you subtract it from the function, it turns into vertical movement. So x minus 5 squared, and then left 3 is, this time we are adding it to the opposite when you deal with horizontal movement. Left one is x plus 1 squared. Now reading about our question, it says 1 unit right. So if it says right, you'll subtract it and then keep that exponent the same. We just modified the variable this time. With the horizontal movement, you modify the variable. With the vertical movement, you modify your whole function. So after the next example or the one after that one, I will kind of like put a lot of examples on the board for you to figure out what the pattern is going to be. So if you're going to have like a lot of examples at once, it's going to take a few seconds. So right here, the function is going to be again x minus 1, because we are moving it 1 unit to the right, and then square the function we have. Okay, moving up one level. Now the next transformation is reflection across the x-axis. What does that mean? So when you reflect a function on the over the x-axis, what you do is you just put a negative in front of everything on the right side. What does that mean? So basically, whatever you have on the right, you're going to write it in the parentheses and then put a negative in front of it, and then distribute that negative. Oops. Distribute that negative. So it is easier, and you cannot make a mistake with the example given, but you can make a mistake if you have a polynomial. If you have a binomial, then you can make a mistake. I'll explain what I mean. In here, let's just first solve this question because it's easier than what I want to show you. When you have this function over here, if you want to reflect it over the x-axis, reflection over the x-axis basically tells you to put a negative in front of your right side. I only have one thing on the right side. When I put negative in front of it, that's what it's going to look like. So the answer to this question is going to be like that simple. Negative and then x squared. So now here are the examples that I want to show you. All of them are going to be about reflecting over the x-axis. Reflect over the x-axis. Now let's just have some examples over here. Like, let's start with something easier. Oh, since this is quadratics, but let's just keep it the same. Okay, x squared plus 1, x squared minus 3. These 3 would be enough. Basically, then these are all like f of x equals. On the right side I have x, put a negative in front of it. On the right side I have x squared plus 1, put a negative in front of it. Not just in front of the first term, in front of the whole thing. This is what I mean. If you have a binomial or a polynomial, then it could turn into a problem because you need to distribute that negative into the parentheses, and then the answer would become this. And then in here, basically change all of the signs you have. So x squared turns into negative x squared, negative 3 turns into positive 3. So that would be the change when you do reflection across the x-axis when you have multiple terms, like more than one. But if it's just one term, just change the sign. That's how simple it is with the reflection. So you might want to take notes out of what I say over here because you may not remember everything at once. But if you use your notes and then solve enough questions, then you're not going to need those notes at one point, and then you'll be solving these questions independently. Okay, the next one, let's do the next one. Let's keep a level. Okay, translation 10 units, right? I don't understand how this is another level, because the function is f of x equals x squared, and then we will do right 10 units. Translation, it will turn into g of x after that translation, and then what it will be equal to, remember what I told you about horizontal movement. Think about the opposite of what you think is the right thing. When it says right 10, I feel like I need to add 10 units, but we need to subtract. But we are not going to subtract it from the whole function. This is not what we are going to do. If we do it this way, this means pull it down 10 units. Translation down 10 units. But that's not what we want to do. We want to subtract that 10 from the variable. That's the variable. Subtract 10 and then square this whole thing. Originally, our variable was squared. Now this is the new variable. Whatever you see in the parentheses, that's the new variable. Now you're squaring that one. Okay, that would be the answer to this question. X minus 10, and then you gotta square the whole thing. Let's move up another level. And then in the next level, let's see what is going on here. Okay, this is the last one, and then I will just write some examples, and hopefully we are going to finish this assignment in under 20 minutes. Okay, write your answer in the form. Okay, by the way, this form, for those who are not aware about what that is called the vertex form. So if you have never seen this form before, and if you need more information about it, click the link at the top. I recorded a lesson about vertical form, vertex form, so you can watch that video out and then get more information about the vertex form. If not, let's just continue. Okay, let me see if there was any information at the top, because this doesn't seem to be enough. I think we need more information. Okay, yeah, that's what I need. Let's clear this up. Okay, so our original function is x squared, and then they took it and then did some transformation, ended up with this. So remember what I said in the first example. F of x equals x squared. There's a particular way on the coordinate plane. Like the vertex of that graph, or the peak point of the graph, is at the center of the coordinate plane. Now, how do we move that blue curve and then turn it into something that looks like the green? If we just drop it down 1 unit, down 1, and then it'll become at this point, and then 1, 2. So it looks like it is translated down 1 and then right 2. So down 1, right 2. That's my translation. How do I do it? Vertical movement is always easier to do the first. So this means down is subtract 1 from the end of the function, and then this right is horizontal movement. It's like, think about the opposite of what you believe is the right thing. So instead of adding 2, we are going to subtract from the x. X is the variable. What we have in the parentheses is the variable. Subtract 2 for the right, and then in the end, right before the end, let's just do this, square that thing, and then this one here, down 1, tells you to subtract 1 from the whole thing. Now let's just write what we ended up with. We subtracted 2 from the variable, it was squared, and then in the end we need to subtract 1 for the vertical translation. That would be our answer for this question. X minus 2, and then put it in the parentheses, square it, and then subtract 1. Now let's just use this space to do a quick recap. Okay, let's say this is our original function, and then these are what we have. And then Okay. X minus 3 or 2 squared plus 1, x plus 5 squared minus 2. Okay, let's just do all of them at once and then we're going to be done. So basically, we are subtracting 1 from the whole thing. That's down 1. Adding 3 in the end is up 3. Changing the sign of x squared is reflect over the x-axis. This one here, the sign has changed and then we subtracted 2, right? So reflect across the x-axis and then subtract 2 from the whole thing. That means down 2. It is also can be obtained by let me see, translating it up 2 units and then reflecting over the x-axis. I don't want to explain it in this one because this is a basic assignment and that's a little more complex than what we are dealing with right now. So over here, this one can be obtained when you do this. That's left 2 because it's only affecting the variable, and this one here is in the end added up. That means up 1. And in here, left 5 and then down 2. Okay, that was it for this assignment, guys. I hope you now understand how to do the translations, reflections, and we have not done any rotations in this assignment. Yeah, translations and rotations and the combination of both of them. So thanks for watching. I hope the video helped you out. Comment below if it did, and I hope to see you in another assignment or video.